Hey friend, it's Dastardly Dani. I picked up your distress signal. I see you drifting into deep space, but you're wide awake. Don't worry, I got you.
Today we're going to be reading the Apollo Operations Handbook, Lunar Module Volume I with subsystems data. I found this laying around somewhere. It's a good time. So let's get started, shall we? It's dated September 15th of 1969. Quite honestly, one day after my birthday. I wasn't born in 1969, don't be rude. But I was born in September 14th of some sort of year. So, I'm not going to read this. Because this is just a list of effective pages. And then this is a table of contents. So, I will read, however, the change information. So, let's get to it. This handbook is subject to continuous change or revisions on a priority basis to reflect the current lunar module or mission changes, or to improve content or arrangement. The content and the changes are accounted for by the list of effective pages in the following means. Record of publication, the publication date of each basic issue and each change issue is listed below as a record of all editions. Page change date. Each page is this handbook. In this handbook has space for entering a change date. The latest publication will be entered in this space each time a page is changed from its basic issue. Got some comments here, NASA comments, and suggest changes to this handbook should be directed to M.E. Dement Flight Crew Support Division, Spacecraft Operations Branch Building Number 4, MSC 2101, Webster Seabrook Road. That's it. I'm going to move forward now. Got some more lists of illustrations here. Awesome. Going right into section 1, talking about the spacecraft. We're going to talk about the introduction. This section includes descriptions of the LM, the LM-SLA, SIBB connections, the LM-CSM interfaces, and the LM stowage provisions. The Apollo Saturn space vehicle configuration is shown in Figure 1-1. The LM configuration is designed for manned lunar landing missions. It consists of an ascent stage and a descent stage. The stages are joined together at 4 interstage fittings by explosive nuts and bolts. Subsystem continuity between the stages is accomplished by separable interstage umbilicals and hardline connections. Both stages function as a single unit during lunar orbit until separation is required. Stage separation is accomplished by explosively severing the 4 interstage nuts and bolts, the interstage umbilicals, and the water lines. All other hard lines are disconnected automatically at the stage separation. The ascent stage can function as a single unit to accomplish rendezvous and docking with the CSM. The overall dimensions of LM are given in Figure 1-3. Station reference measurements in Figure 1-4 are established as follows. The Z and Y axis stations reference measurements in inches, starting at points where both axes intersect at the x-axis at the vehicle vertical center line. The z-axis extends forward and aft of the intersection, the y-axis left and right. The point of the intersection is established as is 0. The positive y-axis measurements increase to the right from 0. The negative y-axis measurements increase to the left, similar to the positive and negative z-axis measurements increasing forward and aft from 0. The x-axis station reference measurements, also in inches, start as a designed reference point identified as station plus x 200,000. This reference point is approximately 128 inches above the bottom surface of the footpads, with the landing gear extended, mind you. Therefore, all x-axis station reference measurements are plus X measurements. In the ascent stage, the general description is the control center and man portions of the LM accommodates 2 astronauts. It comprises of 3 main sections: the crew compartment, the midsection, and the aft equipment bay. The crew compartment and midsection make up the cabin, which has approximately overall a volume of 235 cubic feet. The cabin is climate controlled and pressurized to 4.8 to 0.2 psig. Areas other than the cabin are unpressurized. The structure you're going to see in figure 1-5 in the ascent stage has 6 structural areas: crew compartment, midsection, aft equipment bay, thrust chamber assembly or the TCA, cluster supports, antenna support, and thermal and micrometeoroid shield. Cool. Look at that. I see the antenna. There's actually 2 antennas in a docking window. 3 antennas. 4 antennas? 5 antennas. I'm reading 5 antennas. Is there another antenna? I'm not. 6? There's 6 antennas. It's 7. I'm not exaggerating. If you're awake during this part, you could fact check me on this, but there are 7 antennas on this thing. Actually, the design is pretty cool. I'm not gonna lie to you. So it's 13 feet, 10 inches wide without the leg extensions, and about 31 feet with the leg extensions. How tall is this bad boy? 28 feet? It's pretty small. Sorry, I'm putting myself to sleep actually. What the heck? Okay. The crew compartment. The crew compartment is the frontal area of the ascent stage. It is 92 inches in diameter and 42 inches deep. This is a flight station area. It has control and display panels, armrest, body restraints, landing aids, 2 front windows, a docking window, and an alignment optical telescope, or the AOT. Flight station center lines are 44 inches apart. Each astronaut has a set of controllers and armrests. Circuit breaker control and display panels are along the upper sides of the compartment. Crew provision storage space is beneath these panels. The main control and display panels are cannied and centered between the astronauts to permit sharing and easy scanning. The optical alignments, an optical alignment station between the flight station is used in conjunction with the AOT, a portable life support system, or the PLSS. Donning station is also at the center aisle, slightly aft to the optical alignment station. I'm going to start using aft more often in my vocabulary, which I believe means back. The crew compartment shell is cylindrical and of semi-monocoque construction. Monocoque. Semi-monocoque construction. It is a fusion, welded, and mechanically fastened assembly of the aluminum alloy sheet and machined longerons. I would know this stuff, because I'm in space right now, but this is from 1969. This is so old, I don't recognize it. It's fine. The shell has an opening for the docking window above the commander's flight station. The front face assembly of the crew compartment has 2 triangular windows and a forward hatch. 2 large structural beams extend up the forward side of the front face assembly. They support the structural loads applied to the cabin structure. The lower ends of the beams support the 2 forward interstage mounts. The upper ends are secured to an additional beam structure that extends across the top of the crew compartment shell and aft to the midsection structure. The crew compartment deck measures approximately 36 by 55 inches. It is constructed of aluminum honeycomb bonded 2 sheets of aluminum alloy. Non-flammable Velcro pile strips which contact hooked Velcro material on the astronaut's boots are bonded to the deck surface. Hand grips recessed to the deck aid the astronauts during the egress and ingress through the forward hatch. Perforated glassed reinforced plastic covers the ceiling above the flight stations. A handrail with 5 green radioluminescent discs attached to it is bolted to the left-hand structural beam of the front-faced assembly. Okay, we got some pictures going on here. Here are the 2 astronauts. Here he is standing up, so here's where the boot would be velcroed. And here are some really cool dance moves that you would do inside of the spaceship. Gosh, amazing. I love this for us, guys. We're getting so much done overall. How long is section 1? I'm 24 pages in. I've only read like 3 pages. I'm still in section 1. Still in section 1. Lord Jesus Christ. Just a lot. Just a lot going on. No. I'm in section 2 here. How did I get to section 2? This is section 2. 2. Section 2. I missed it. Alright, so we got like 12 pages to go. That's fine. That's totally fine. So good. I love reading this. It's my favorite. I need to stop breaking character here. Okay. Control and display panels. The crew compartment has 12 control and display panels. 2 main display panels, 1 and 2, that are canted forward by 10 degrees. 2 center panels, 3 and 4, that are sloped down and aft 45 degrees towards the horizontal. 2 bottom side panels, 5 and 6. 2 lower side panels, 8 and 12. 1 center side panel, 14. 2 upper side panels, 11 and 16. And the orbital rate display, Earth and Lunar Ordeal panels aft to the panel 8. Panels 1 and 2 are located on each side of the front-faced assembly center at eye level. Each panel is constructed of 2 0.015-inch thick aluminum alloy face sheets spaced 2 inches apart by formed channels. The spacer channels are located along the sheet edges. Additional channels inboard of the edge channels reinforce the sheets. This form of rigid box-like structure with a favorable strength-to-weight ratio and a relatively high natural frequency. 4 shock mounts support each panel on the structure. Panel instruments are mounted to the back of the surface of the bottom and or to the top sheet of the panel. The instruments protrude through the top sheet of the panel. All dial faces are nearly flush with the forward face of the panel. Panel 1 contains warning lights, flight indicators, and controls, and propellant quantity indicators. Panel 2 contains caution lights, flight indicators, and controls, and reaction control subsystems, also known as the RCS. And environmental control subsystem, which is the ECS, indicators and controls. Panel 3 is immediately below panel 1 and 2 and spans the width of these 2 panels. Panel 3 contains the radar antenna temperature indicators and engine, radar, spacecraft stability, event timer, RCS, and lighting controls. Panel 4 is centered between the flight stations and below panel 3. Panel 4 contains attitude controller assembly, or the ACA, and thrust translation controller assembly, which is the TTCA controls, navigation system indicators, and the LM guidance computer, which is the LGC indicators and controls. Panels 1 through 4 are within easy reach and scan of both astronauts. Panels 5 and 6 are in front of the flight stations at astronaut waist height. Panel 5 contains lighting and mission timer controls, engine start, stop, push buttons, and the X translation push button. Panel 6 contains abort guidance controls. Panel 8 is at the left of the commander station. Panel is canted up to 15 degrees from the horizontal zoning. From the horizontal. It contains controls and displays for explosive devices, audio controls, and the TV camera connections. Panel 11, directly above Panel 8, has 5 angled surfaces that contain circuit breakers. Each row of circuit breakers is canted 15 degrees to the line of sight so the white band on the circuit breakers can be seen when they open. Panel 12 is at the right of the LM pilot station. The panel is canted 15 degrees from the horizontal. It contains audio, communications, and communications antennas, controls, and displays. Panel 14, directly above Panel 12, is canted up 36.5 degrees from the horizontal. It contains controls and displays for electrical power distribution and monitoring. Panel 16, directly above Panel 14, has 4 angled surfaces that contain circuit breakers. Each row of circuit breakers is canted 15 degrees to the line of sight so that the white band on the circuit breaker could be seen when they open. The ordeal panel is immediately after Panel 8. It contains the controls for obtaining LM attitude. With respect to the local horizon... horizontal from LGC, forward hatch, in figure 1-8. The forward hatch is in the front face assembly, just below the lower display panels. The hatch is approximately 32 inches square. It is hinged to swing inward on quick release hinge pins when opened. A cam latch assembly holds the hatch in the closed position. The assembly forces a lip around the outer circumference of the hatch into a preloaded elastomeric silicone compound seal that is secured to the LM structure. Cabin pressurized... What's going on with me? Cabin pressurization forces the hatch lip further into the seal, ensuring the pressure-tight contact. A handle is provided on both sides of the hatch for the latch operations. To open the hatch, the cabin must be completely depressurized. The hatch must be opened by rotating the latch handle. A lock pin and a plate over the latch can be withdrawn to release the latch in an emergency. The cabin can relieve a dump valve, and dump valve can also be operated from outside the LM. An antibacterial filter is stowed at the center of the hatch inside surface. Prior to depressurizing the cabin for astronaut exit to the lunar surface, the filter is removed from its storage support and affixed to the cabin relief and dump valve before the valve is open. Opening the valve with the filter in place prevents cabin air contaminants from being expelled through the valve. Great. Next section is windows, but you better be asleep at this point. Okay, get it together. Okay. Alright, we're going into windows. This is very exciting stuff. Okay. I'll be really surprised if you're still awake at this point. But anyways, windows, as seen in figure 1-9 and 1-10. I guess that triangular windows, and then there's like, I don't know what they are. Apollo. This caveman like. All right, 2 triangular windows in the front face assembly provide visibility during descent, ascent, and rendezvous and docking phases of the mission. Both windows have approximately 2 square feet of viewing area. They are canted down to the side to permit adequate peripheral and downward visibility. A third docking window is in the curved overhead portion of the crew compartment shell directly above the commander's flight station. This window provides visibility for the docking maneuvers. All 3 windows consist of 2 separated panes, vented to the space environment. The outer pane is made of bicore glass with a thermal multilayer blue-red coating on the outboard surface and an anti-reflective coating on the inboard surface. The inner pane is made of structural glass. It is sealed with Rayco seal. The docking window inner pane has a dual seal and has defog coating on the outboard surface and an anti-reflective coating on the inboard surface. Both panes are bolted to the window frame through retainers. All 3 windows are electrically heated to prevent fogging. The heaters for the commander's front window and docking window receive their power from 115-volt AC bus A and the commander's 28-volt DC bus, respectively. The heater from the LM's pylon front window receives power from a 115-volt AC bus D. The heater power from the commander's front window and docking window is routed through the AC bus A, CDR, wind, heater, and heaters, dock window, circuit breakers, Battlestar Galactica. These... Where am I? These are 2 ampere circuit breakers on panel 11. The temperature of the window is not monitored with an indicator. Proper heater operations directly affect crew visibility and therefore visually determined by the astronauts when condensation or frost appears on the window that the window heater is turned on. It is turned off when the abnormal conditions disappear. When window shade is closed, that window heater must be off. That makes sense to me. I get that. Midsection. The midsection structure of the ring stiffened semi-monocoque shell. The bulkhead consists of aluminum alloy, chemically milled skin with fused welded... What is that word? I'm gonna learn how to say it right here, right now. What am I doing? Hold on. Yeah. Longerons. What? I'm not even... Longeron? Longeron? Are you serious?
Longerons.
I don't have my headphones on. Hold on.
Longerons. Longerons. Longerons.
No, I feel like I've been saying it right. But over here it says Longerons. AI is wrong. YouTube is right. Longino. Okay, moving forward. Yeah, I tried to find other stuff for you guys, but I couldn't find anything. Okay. I'm gonna go with Longerons. Ugh. The bulkheads consist of aluminum alloy, chemically milled skin with fusion welded longerons and machined stiffeners. The midsection shell is mechanically fastened to the flanges of the mayor. It is flanges. I'm pretty sure it's flanges. This is one of those words that I know the word, but I'm being dumb. Flange. That's gonna wake anybody up. That was rude. Thank you. Flange. The midsection shell is mechanically fastened to the flanges on the major structural bulkheads at the station, plus Z27.00 and negative Z27.700. The crew compartment shell is mechanically secured to an outboard flange of the plus Z27.00 bulkhead. The upper and lower decks at station plus X294.643 and plus X233.500 respectively are made of aluminum alloy. Integrally stiffened and machined, the lower deck provides structural support for the ascent stage engine. The upper deck provides structural support for the docking tunnel and overhead hatch. The two main beams running fore and aft integral with those above the crew compartment are secured to the upper deck of the midsection. They support the deck at the outboard end of the docking tunnel. The aft ends of the beams are fastened to the aft bulkheads, which have provisions for bolting the tubular truss members that support both aft interstage fittings. Ascent stage stress loads applied to the front beam are transmitted to the two beams on the upper deck to the aft bulkhead, and through the aft interstage support members to the fittings. The combination of beams, bulkhead, and truss members form a cradle around the cabin assembly. It takes up all the stress load applied to the ascent stage. Two canted beams assemblies secured to the bottom of the lower deck to the forward and aft bulkheads form the ascent stage engine compartment. The engine support ring truss members are bolted to the lower deck. The engine support ring truss members are bolted to the lower deck. The right side of the midsection contains most of the ECE controls, ECS. The right side of the midsection contains most of the ECS controls and most of the heat transport section water glycol plumbing. Valves of the operation of the ECS equipment are readily accessible from the crew's compartment. The left side of the midsection contains a waste management section, a portable life support system, the PLSS, and other crew provision stowage, guidance, navigation, and control subsystem, the GNCS. Electronic units that do not require access by the astronauts are located on the midsection aft bulkhead. These units include an LM guidance computer, a coupling data unit, a power and servo assembly, and a signal conditioner assembly. RCS propellant banks are installed between the midsection bulkheads on each side, external to the basic structure of the midsection. The ascent engine propellant tanks are mounted in the midsection beneath the RCS tanks. A ring at the top of the ascent stage is compatible with the clamping mechanisms in the CM. This ring is concentric with the x-axis, which is also the nominal center line of the thrust of the ascent and descent engines. The drogue portions of the docking mechanisms is secured below this ring during the docking operations to mate with the CM-mounted probe. It is also stored in this area when storage is required out of crew compartment. Alright gang, that's all for tonight's reading. You've made it through a section of the manual and hopefully into a peaceful orbit of dreams. Sleep well, and I'll see you on the next mission. And if you ever need me, just click on that next video.